And cement has most highest environmental impacts. One, for the energy that it takes to make the cement.
Okay.
And we've always known that. But what we've discovered now was that the embodied carbon dioxide release in making a ton of cement puts a ton plus 400 pounds of carbon dioxide into the
I
atmosphere.
had no idea.
Yeah.
This is Peak Moment. We are living at a peak of human innovation, information, wealth, and health. But we're also at a peak of population and consumption, with rising temperatures and declining resources fueled by cheap oil and gas. Peak Moment Television, bringing you examples of positive responses to energy decline and climate change through local community action.
Hi, welcome to Peak Moment. I'm Janaea Donaldson. I'm in Port Townsend, up in the Puget Sound of Washington State, and I'm at the home of Chris Stafford. Thanks for joining me.
Thank you, Janae.
Chris, you're an architect and a builder, and we're at your home that you've built with some ecological principles in mind. How did you get into thinking about the environment and buildings?
Well, I've been very active in all of this, in the development of the sustainable thinking in the building industry since in the mid-'80s.
That's a long time.
When I worked on national AIA committees, American Institute of Architects committees, environmental committees. And our focus was to try and get the rest of the profession to be more environmentally responsible and think more environmentally about, incorporate that in their projects.
In terms of the materials they're using, the processes?
At that time it was more to just get the AIA to be aware of environmental issues.
Okay.
It wasn't until 1990 that we started the Committee on the Environment, where we're really dealing with the industry as such, trying to make them more aware. And in that time we were dealing with the full spectrum, because we understand that all of this has to be an integrated process. So we dealt with site, we dealt with materials, we dealt with size, we dealt with energy. And that's going on, but I served on the steering committee for the first 3 years on that. And then after that, I decided that it was time to not spend so much time in Washington on national committees, but to come back to my region and try to make change happen here.
So what did you do? What was the changes scene that you went to?
Well, I started working in my practice, and I was doing, actually my practice was three-pronged. I was doing workshops around the country, I was doing consulting to government agencies, and then I had a small architectural practice in addition to that. And that practice sort of blossomed in doing straw bale design for straw bale houses.
Straw bale houses.
Yes, right.
So you're using bales of straw, just
Correct.
give us a concept of this, and then what happens, just basically?
Well, we stack them up for the exterior walls, and then that's about the only thing that's straw bale, at least with the ones that I designed. After that, you put a top plate on, and then your roof structure is similar to any other roof structure we have. And then plaster, and at that end, for the seismic concerns in this region.
That's right, you got earthquake country here.
Same as
in California. That's right.
So in these areas, we pretty much have to go with a cement stucco exterior. And in this region, we don't have that much clay to deal with earthen clays and earthen plasters.
So then you moved from straw bale for some reasons. And
well, I
what
took the straw bale and went to Europe and worked in Greece and did one house there and had another client there for a while. But there we were doing natural building, and I was designing houses with mud and straw and using the traditional technology of the residential, farmers' residential buildings, and replacing the stone walls with bales, but using cane roofing on top of logs, and then on top of that clay roofs and this sort of thing.
Interesting. I bet you enjoyed just the diversity of all the places and materials you got to work with.
And from there I went to Saudi Arabia and worked on projects in Saudi Arabia, doing natural building in Saudi Arabia. So when it came time for my wife and I to rethink where we were living. We were living about 7 miles west of here. And we found that we were coming into town about 3 times a day. And you know, even 7 miles is here, and
Yes,
we could
that's
avoid
right.
it by
That's right.
living in town.
Okay.
So we decided to move in town, and then we found this site that we're on now. And then I started designing for the site, and also to be environmentally responsible in our decision, how we make our decisions.
So this site, part of what I see is this house looks like, quote, a regular house. You're designing a house like the mainstream folks would be familiar
Exactly,
with.
right, because my whole emphasis has been to get the mainstream to change the way they think about how they live and how to live more sustainably.
So what have you done in this house? What kind of things have you done that have those, that are hallmarks of or examples that demonstrate that?
Well, mainly we designed a much smaller space.
Uh-huh.
And we want to be able to show that people can live in a smaller space comfortably without major lifestyle changes.
And so how big is the space in your house?
The house is about 1,500 square feet.
And it's got two
stories,
right?
And that doesn't include a basement, which we could get in because of the slope on the site. So we have, at the basement, we've got a 3-story house.
My goodness.
Yeah. But that isn't included in the 1,500 square feet.
Right, okay. In the living space
Right,
is 1,500 square feet,
right.
which is very comfortable for 2 people, I
It
would
is,
assume.
and it's very adequate for everything we need. We spend a lot of our time in our offices. My wife's studio and my office.
Which you're on site?
It's on site.
Okay.
It's about 700 square feet total. And she has the downstairs and I have a loft upstairs. So,
So the stacking is a part of that factor.
yeah, and I think in this urban situations, you're going to have to.
We're going to have to go up,
develop
up and down,
go up,
right? Verticals
exactly,
are
yeah.
our dimension. Now, what's nice also, you mentioned here, is that we're sitting in the courtyard, which is partly facing out into the public
Right.
space, but between the plants, it's sort of semi-private.
Right, but it's a public-private space. It's where the people that come in can feel like they're coming into our property.
That's right.
But yet it's out
And
facing the
it's
public.
very welcoming. I love, and it's kind of a
Right.
corner. And then you also have a private space that's outdoors.
Behind this, then, we have a studio and the house sort of make an L.
Yes.
And in that L, we filled it in with a deck that's over the daylight basement and over the garage, basically, which is down there. Which then the deck links the two and becomes our outdoor space and our very private space.
Right.
Yeah.
What other things did you do? Partly it was siting, I understand, from a smaller space. What else did you do that is environmentally friendly here
Ooh.
in your building design and so
Sure.
on?
Well, I think first, just in design, you've got to start considering the site, and you've got to think about what conditions have to be overcome by the design.
Okay.
As you can hear, we've got a lot of street noise. So fortunately, the street was on the north side of this house, so we could minimize the amount of windows we had on the north side.
Right.
Also reduce the street noise in the house.
So the north facing is sort of a kind of a wall, is
It's
not
a-
maybe the
yeah,
right word, but
it-
basically a wall against the sound.
Against the sound, against the noise, against the north weather
Yes.
coming in, the
Okay.
colder weather. And so that was a strong consideration to make. And then we developed it this L so that we got the private space. And then we started looking at the materials we'd use. Just in starting with the foundations and the foundation walls, they had to be concrete, or we decided to use concrete, but we could use a 50% cement replacement with fly ash.
Fly ash.
Fly ash, which it's the ash that flies off of coal fire incinerators or coal fire generators.
So you're really taking a waste product.
A waste product
and
that has to
reusing
be
it.
disposed of. We're using it to replace cement. And cement is basically one of the, is not basically, but is one of the highest environmentally, has the most highest environmental impacts on the environment.
I didn't realize that.
Right, one for the energy that it takes to make the cement,
Okay.
which is, I don't have the numbers.
But it's a lot of, okay.
And we've always known that. But what we've discovered now, 10 years ago, was that it also produces a lot of carbon dioxide.
Wow.
The embodied carbon dioxide release in making a ton of cement puts a ton plus 400 pounds of carbon dioxide into the
I
atmosphere.
had no idea.
Yeah.
So all these concrete buildings and foundations we're doing are just increasing
Right.
our
Definitely.
greenhouse gases.
Yeah, and concrete
Ooh.
is something we really can't avoid using. It's necessary. It's plastic, we can mold it.
Right, right.
But
But now
what
you've
we're
got something
trying
that
to
you
do
can
is
start to reduce
we reduce the amount
you
that
need.
we need by building smaller. We reduce the amount that we use by building smarter.
Mm-hmm.
And then reduce the amount of cement we use by adding fly ash.
Right, right.
And when I say building smarter, I'm thinking that when contractors, they think, well, if 6 inches will work, 8 inches will be better. And
Yes,
so
yes.
what we want to go is go back to the 6 inches that we need and not add that additional cement that's superfluous.
Right,
Yeah.
right. Okay.
So it's, and then we can, there are tricks that we use where there's called a Fazwall product that is basically a fiberglass curtain or fiberglass fabric that we tack to 2x4s and use for our form work for the footing. So we use much less farm work, goes up quicker, it's easier to take down, we have less waste.
What other materials did you employ in here in your?
Then in terms of the house itself, the structure of the house, unfortunately, it was not too good in a way because I designed it for frame construction because I had been serving on a committee of a company that did FSC certified forests for the forest
So
management
FSC
is a Forest Stewardship Council's
Okay.
certification
So
program for
using good wood or
using environmentally responsible managed forests
okay,
that took out material without destroying the ecosystem
okay, good.
and also supported the communities. And so it had a social and economic. So I was interested in using FSC certified lumber, but the time that it would have taken to have gotten it here, and I just didn't plan ahead far enough. So I had to use lumber off the shelf that wasn't certified. But I used it in a way that took less lumber. And I used it in by what's called a system called inline framing or advanced framing system, where you use studs 2 feet on center.
Yes, yes.
You use a two stud corner, single stud top plate, single stud
So
bottom
you're gonna have
plate.
less waste.
And right, so you have about a 20–30% savings in lumber in your exterior framing lumber that way.
We have about 2 or 3 minutes. I want to
Okay.
make sure that we, yeah.
Okay.
So you get the highlights
All
of,
right.
of what else
So-
you did for your
Right.
structure.
Then I understood, and people, this is before the oil situation happened, but I understood that we were going to be paying a lot more for our energy. So I wanted this house to be very energy efficient. And one way of doing it was encapsulating the house with using a foam insulation.
Okay.
So we had very little heat loss.
Spray and foam kind
Spray
of
and foam
insulation.
called an
All right.
Icynene.
Okay.
And so then we wanted to use a very simple heating system, and we have a radiant hot water system that is used to preheat the water that heats the house.
So your house is heated by hot water,
Not in the floor,
not on the floor.
but I have
pretty-
small little unit heaters
Ah,
in the walls that I use, and I have 3 downstairs and 2 upstairs.
So the preheating is done with sun, with the solar,
the solar
thermal collectors.
the solar collectors preheat the water.
Aha.
Then that's for both for domestic as well as for heating the house.
Do you have to have separate pipes for those two uses?
No, actually they're both. It's domestic water that goes through the heating
It's
system.
just, that's nice.
So,
So
yeah,
that's a good
yeah,
economy
yeah,
there
right.
of piping.
And then in addition to that, for our energy, all of our light fixtures are compact fluorescent. And then we use photovoltaic to generate, we're grid tied.
Which we'll take a little tour. We'll see that one.
Right, okay. So so I guess that's the main
So-
thrust.
so-
And then all of our materials are in an effort to be non-toxic and compatible with all of our kitchen cabinets, all of our floor finishes, all of our wall finishes.
Are non-toxic.
Non-toxic.
Aha.
And our roofing is metal, which is a durable material, but it's metal. Steel is about 26% recycled content.
Oh, that's
And,
okay.
you know, so we know that there's
There's at least some of
recycled
that's coming
content,
back into the flow of things.
And then you can see our rainwater collectors in the back behind us.
Which we get to have a tour of.
And that's mainly used for irrigation, the lawn yard irrigation.
So part of what I want to do is just, we'll get a tour here in just a second. Part of what I want to point out is that you had the rainwater and the photovoltaics and so on in your mind when you designed this.
That's correct.
But you added them on after you'd built your main structure?
Well, no, I didn't add, no. They weren't the driving force of the design of the house.
Okay.
The driving force was the siting and site considerations.
Okay.
I was aware of where the sun was, but you notice I didn't put my roof so it faced south.
Right.
There were other reasons I wanted the house to be shaped it was, and so I added photovoltaics on a stand by themselves that track the sun without having to design the house differently than what I wanted for the house.
Part of what I wanted to point out about that, and we'll go take a look at them next, is that people can add some of these energy saving systems
that's true.
later,
Yes.
based on and don't have to have had a house designed just for them.
Right, and they don't have to be wired for them.
Right.
Or-
Well, let's go look at the
Okay. Be
photovoltaics
happy to.
first, and then I want to
Okay.
go see the rainwater catchment
All right,
afterwards. That's
okay,
fun.
Okay.
So, Chris,
Yes.
the solar panels that you have here, which you designed not to be on the house,
Right.
so that, like other people may do, they could be added later for some people.
Right, and they could. Yeah, in my design, I had many different criteria to design toward. One of which was to have the house and be facing otherwise, so that I didn't have room for the PVs on the roof. And the photovoltaics are on a trackable array, mounted on a pole, separate from the house,
Okay.
which works very fine.
So they're tracking the sun.
They track
they're
the
following the
sun.
sun, so you get more
Yeah.
return.
Right,
from
we
them.
do. We have a 2.2 kilowatt size array, and then by having it solar tracking, it actually generates about 30% more than if it were a fixed array.
Nice.
Yeah.
So then this energy that the electricity that you're collecting goes back into the grid.
Right, it would go through an inverter, and then we say it's grid tied. So the grid takes what I don't use, it goes into the grid. I get credit for it so that I can use it, basically
offset when you
use
do need
those credits
electricity.
later. Right. Yes.
But you also did something interesting. You put in some batteries as well.
Yeah. Well, we're in a community that we lose our energy in the wintertime. In storms, the energy can get
So you
knocked
get power
out.
outages.
And so just after we moved in, actually, we had a major power outage in the north end of Peninsula, and I had forgotten that our outdoor light was on. Well, that happens to be on the circuit that has a refrigerator and our pumps for our heating system, and all of that's
the
on.
important life systems
Right,
for you.
on the batteries. But this was one of that circuit, so in the middle of the night I checked and I realized that our front light is on, and we had the only light on in a 3-county area, and it's like I was thumbing my nose at the community for, look what I've done.
Maybe a different way to think about it is that you were a beacon light of what the rest of the community ought to be doing as well, is to be having resilience in your energy systems.
That's good.
Whether
I hope that I hope that was a message.
Whether it's power outages, as you may have on the grid, or whether it's times when it's going to get more expensive, and not necessarily in Washington State because you have a lot of hydropower, but in other parts of our world, in other parts of our country that are relying on coal and gas and oil for their electricity.
Right. And I'm encouraging my clients to add more and more power generation equipment. In fact, I'm going to add another kilowatt of energy collectors on the house just because I think we need it.
Just for more resilience.
Yeah, right.
So Chris, the first thing I noticed when we came up, driving up to your house, was this huge round silver thing on the back side of the house and also on the front side of the house.
Yeah, there are two of them.
So what is this?
Okay, this is what I catch my rainwater with this.
Okay.
So that then we use it for irrigating the yard.
So you've got it on the gutter. You've just got a downspout into
Correct,
this.
yeah.
What
And-
is this thing?
Okay, the thing is
It looks like
actually
a
a
cylinder.
culvert.
A
I just went
culvert.
to a culvert company and I ordered, for this one it's a 4-foot diameter.
Okay.
And I think I got it 15 feet long. And then the other one is about 15 feet long with 3-foot diameter.
Okay, okay. And so you had to get something to close it in the top.
Right, I had a top made for it to
Okay.
close it off.
And then and the water just feeds in by gravity?
Water feeds in by gravity into there from the gutters. And then in the tank, it feeds by gravity into the hoses that then we water.
Okay.
And I've got one pipe coming out of the bottom of the tank that goes to a manifold, so I've got 3 or 4 hose bibs
Okay,
on that,
all right,
and then I can
okay.
run my hoses from that.
So how much capacity do your two
This
give
tank
you?
is about 800
Okay.
gallons. The other tank is about 1,000 gallons.
Wow.
And it takes 6 inches of rain to fill them up.
6 inches of rain for...
Well, on the roof.
Okay.
6
all right.
inches of rain on the roof.
So how
And
long...
we get about 12 to 17 inches a year, so
Okay.
it's about
so
half
this
of
is
our
you
annual-
could actually
double my capacity. if I
capacity.
needed to.
How much for your irrigation? And you don't have extensive gardens that
That's
you're
correct,
doing.
yeah.
How long will this water last you for your irrigation?
So far, this tank hasn't lasted what we needed for the
For
summer.
a whole season?
No.
Okay.
Unfortunately, we're on a sand dune here, and the water just goes right
sinks
through.
in.
So my wife is watering every day,
Mm-hmm,
and we were out of water the end of July.
Okay. So somebody that's in a serious rain shadow would be thinking about increasing the capacity to be able to have it last longer into
right.
the season.
Yeah.
But why did you choose this material?
Okay. It's been something I've been thinking about for a long time. I've been thinking about these things that could be structures for buildings, but also rainwater collectors. And then, at the time I was thinking about it, it could be used for water for toilets or whatever.
Sure, sure. Gray water systems, if we were allowed
Yes,
to use
exactly.
that.
And more on a commercial basis or institutional size basis. But so in this case, I just took what I could do, and I found the culverts that aren't structural because they're actually put together in a
with
spiral.
Yes.
And when I bought them, the guy said, well, this may not hold water because it's not a sealed joint. And I said, well, if it doesn't matter, it's just, and we can do something about it if it does.
And you can seal it later
You're right.
if you need to.
And so, but it hasn't been leaking. So it must be the pressure of the water that keeps it
Keeps it full.
yeah.
Because what it strikes me is what's nice about this is it's not a plastic.
Right.
So you're not, if you were wanting to use this for, for weather use, this is going to last longer, I would expect.
Well, I don't know if that's
We'll find
good.
out.
I think it's more attractive than a blue plastic.
Well, I got to admit, it looks sort of like,
Right.
cool new design
right.
kind of a thing.
And I get people coming up and wanting to know what it is. And,
Which is
wow,
great.
I really like this.
I could well imagine in times ahead when water is such a critical resource, we start to replumb our situation so that our toilet flushing and irrigation all come from catchment
Right.
systems, then I'd say you're onto something. We'll see all these little silver silos all over the
right.
place.
Well, but thinking of toilets, you'd asked me earlier about some of the things that we did in the house. Well, our toilets are 2-flush toilets, so we have a full flush and a half flush.
So you're doing
we
conserving water that way.
Conserve water.
Yeah. I'd like to go take a look at the thermal hot water collectors, your hot water,
Solar hot water.
solar hot water.
Okay.
Okay.
Right. Good. We can do that.
So here we are on this lovely deck, beautiful wall facing south, hot sun. What do we
Water
have up
base.
here?
Okay. These are our solar hot water heaters, and they preheat the water for both our domestic hot water and our space heating in the house. And we have in the house, we have heaters, unit heaters, that rather than floor radiant system. So, and then we run potable water through both systems. It's the same potable
Same water.
Same water.
So what the water does is it comes through into these pipes. They're piped kind of things.
Right.
Is that right?
What they are, they're glass evacuated tubes, and they're connected to the manifold. There are 20 of them in this array. And then the water comes through from the bottom in the manifold down in the tube, and the tube heats it, and then the heated water goes out, goes into the next tube, and works its way through the 20 tubes up to the top.
Getting hotter and hotter and hotter and hotter.
And then from there it goes over to our second array, which is out of commission right now. And then moves from there back to our storage tank in the basement.
So, and that's your hot water tank?
That's a hot water storage tank.
And so, do you find that, say, on a summer day, that water is hot enough to do your showers, or does it still need to be boosted more?
Well, it's the way the fins in the tube, the copper fins in the tube, are tilted. They're tilted for maximum sun in the wintertime.
Okay.
So in the summertime, we get very little heat. I mean, in relative speaking.
Right.
And we get about 100-degree heat through there, which is enough for a shower.
Right.
But our on-demand hot water heater kicks on at 120 degrees.
Okay.
Because that's what's needed for the unit heaters to turn on and blow the hot water into the space.
So what your system works is this preheats and gets it up. I mean, in winter, that's nice to get it to 100 degrees.
Yes, and when the sun's out, it gets up that high.
Right.
Yeah.
I have to realize that.
Right.
And then you've got what, a propane or a natural gas demand?
Propane, which is a mistake, which I should have done electricity.
Well, yes, maybe not. We'll see. Right now it's cheaper, right? Probably than electricity. Not in Washington.
No.
That's right. Washington, you have cheap electricity.
Yeah, right.
In California, it would be cheaper.
Right.
So one has to think about where one is.
Right. But what I noticed, what I've been getting, I haven't been getting enough heat in the wintertime. So I've been checking, and I think what we need is our tank is too big for the amount of generation we have. So we're going to add another array, another 20 tube array, and this one comes down and get repositioned so that we can make it more efficient. This will stay where it is.
Well, the good news is you're experimenting for some of the rest of us.
Well, right.
And
I'm learning as I'm going. Yeah. And we're trying to keep as flexible with this as we can. Yeah.
I mean, to think of the fact that you're using these arrays to help heat your house, as well as your hot water, is like a really nice efficiency of using it for both.
Well, yeah, I think so. And if we had to separate them, then one would have to go through a heat exchanger. Sure. And it's less efficient to go through the heat exchanger.
Nice
We'd
design.
lose energy.
Nice design.
Yeah,
nice design.
Right.
Thank you.
You're welcome.
You're watching Peak Moment, community responses for a changing energy future. I'm Janaea Donaldson. Thanks for watching.